onboarding. So we've just done some introductions, and we have some folks that are interested in contributing on the call, some folks who have already started contributing. So we are going to get right into it now. So I'll go ahead and share my screen. All right, so we're starting off here just looking at the Crossplane website, and we'll go to the documentation. One thing I want to mention here is y'all are really valuable as new contributors to the project, or at least early contributors to the project, in that we are trying to do a big push to improve a lot of our documentation. There's a lot of moving parts within Crossplane, so any feedback y'all have or any updates you'd like to make yourself, we welcome those, and it's really valuable, especially to get new perspectives when forming docs. So the main kind of starting point for Crossplane is installing Crossplane itself. Crossplane itself is in charge of a few different things. So when we talk about core Crossplane, that's generally the Crossplane repo here. There's two different binaries that essentially run, or they're actually the same binary, but two different processes that run as deployments in your cluster when you install Crossplane. One of those would be the stack manager. And I don't know if we have a good architecture diagram right now, but essentially the stack manager is in charge of allowing you to install all the different ecosystem of plugins we have to enable new functionality. And then there's the core Crossplane process, which is doing things like things that are common across providers. So scheduling Kubernetes applications, which is how we provision resources to remote Kubernetes clusters. Handling composition, which is something that Muvafiq may speak to later on, and is a newer feature in Crossplane that allows you to kind of aggregate different primitives, manage resources like an EC2 instance and a network group and that sort of thing together. So all of those things that are kind of encompassed in using providers together and aggregating things. That's where we define all of this in the core Crossplane repo. And we'll talk about that a bit today, but I think most of you are interested in contributing to specific providers, which is how we add functionality for a cloud provider or any other SaaS or platform as a service offering. So in order to be able to install these providers, you first have to install Crossplane. So that's where we start off in the docs. Crossplane is installable as a Helm chart. So most of y'all are likely already familiar with Helm. So basically what this will do is install the deployments for the stack manager and core Crossplane. It will also set up some RBAC rules for those. It's going to also install our claim types. So as we're going to get to here when we get to dynamic provisioning, claims are general representations of resources that you may provision on any cloud provider or on any system. So they're generic resource types. So if we look into the APIs here in the Crossplane repo, these are all CRD types that we install alongside the Helm chart. So you'll see these general categories like cache, compute, database, storage, etc. These are all things that are generic, like I said. So these get installed into the cluster with Crossplane, and they're pretty minimal CRDs. If you want to look at the documentation for these, we can hop over here and you'll see there's a number of them. If we look at the types of CRDs that are installed for a database, for instance, we have MySQL instance, NoSQL instance, Postgres instance, etc. So like I said, these are general types, right? So AWS, GCP, Azure, Alibaba, etc. All of those have different representations of these type of resources. And so we call this abstract representation a claim, and the concrete representation. So a concrete representation of a MySQL instance would be something like a GCP Cloud SQL instance. We call those managed resources. So Crossplane is going to bring along these CRDs that are used across different providers. The model here is very similar to persistent volumes and persistent volume claims in Kubernetes. So if you're familiar with how that works, it's going to be a similar model of making claims for infrastructure and then binding to them. I did want to quickly show what one of these resources looks like. So the MySQL instance claim type, and which you'll see here we say is a portable resource claim in Crossplane. is a CRD, so it has the typical metadata of a Crossplane object, so API version, kind, etc. The spec is where things are a little bit more interesting. So when you create a claim, you either reference a class, which we'll talk about in a moment as well, or you do a class selector, which is basically allowing you to select a class based on labels. There's also on some of the claims some fields that are common across any implementation of an abstract resource. So for instance, any MySQL database is going to support the engine version of MySQL, so we surface that on the claim level. The last thing here is that you can reference a managed resource directly. So that's a concrete implementation. So we have in GCP, for instance, a representation of a Cloud SQL instance, or in Azure, a representation of an RDS instance. If you provision one of those as a managed resource, you could then reference it from a claim, which would bind to it, and that's how you eventually consume it, which we'll talk about down the line. And then write connection to secret to ref and some of those things we'll talk about later, as well as the status that is on claims. So this is the general structure of a claim. They're very minimal custom resources that just reference other resources essentially. So after you've installed Crossplane, you have all of these claims present, and you also have this kind of like core machinery for managing the other things that you'll install. So Crossplane by itself, though, without the providers, you're not going to be able to, provision any infrastructure on a remote cloud provider. So you need to be able to install those providers to be able to enable that functionality. So after you have Crossplane installed, you can then go about installing the infrastructure provider you want to use. So these infrastructure providers, and I will hop over to AWS to show, they are just Kubernetes controllers and CRDs. So you could run these without installing them with Crossplane. In fact, when we debug them a lot, I'll have like a local kind cluster going and just go run the command process there and run that against the cluster even without Crossplane installed. So that's one way to do so. However, in a more production scenario and where you want all the features and you may have different providers installed, you want to install that via Crossplane, because Crossplane will take that bundle of controllers as well as the CRDs and will install them appropriately in your cluster. Make sure you're not stomping on any other CRDs that exist, and also give your controller appropriate permissions to operate on resources that you create. So if we look at something like a GCP provider here, we're going to create a namespace, or I'll do AWS since that's kind of primary focus here. They're pretty much the same. We're going to create a namespace, and then we're going to create a cluster stack install. This is also a CRD type that is installed by Crossplane. So if we go back here, you will see, let's see, cluster stack installs down here. So this is a CRD type. And let me go down to spec. And most of these kind of things you don't have to specify. Here we're only specifying the package. So the Docker container that is published for provider AWS or provider GCP, et cetera. And what Crossplane is going to do is going to pull that Docker container, which the container actually has bundled inside of it the CRDs and the different permissions it needs and dependencies. And then it's going to unpackage that in your cluster. It's going to set up your AWS controllers running, which watch your AWS resources. And it's also going to install the CRDs that are associated with it. So doing this is going to start your AWS provider. I believe right now I actually have something running here, which I can pull up. So I have a cluster already set up here. And if we look at the pods, I'm actually using Azure here. You can ignore the default here, but you can essentially see that I have the Crossplane Stack Manager. I would normally have a Crossplane pod running as well. I actually did not install that here so that I could run the Crossplane controller directly against the cluster. I was doing some debugging. And then you'll also see this provider Azure controller. So to install that, all I did was go to this section here and create these resources, although I created it in the Crossplane system namespace. And if we actually look at the CRDs that are present, let's just look for Azure ones. You'll see that when we installed it, we get all these Azure types, like an AKS cluster, a Cosmos DB account, MySQL Server, etc. You'll also see, if we look at Crossplane more in general, you're going to see some of the more generic classes that come directly from Crossplane, like Redis clusters.cache.crossplane.io. That's one of the claims we were looking at earlier. And then we actually have this Redis managed resource that Azure implements. So it's compatible with that claim type. So after you have that installed, you can then go about creating infrastructure on your different providers. So in this case, AWS or Azure or GCP, Alibaba, etc. But first, what you have to do is configure your cloud provider account. So we have different guides here for these 3 cloud providers. Basically, what you're doing is just getting credentials, storing them in a Kubernetes secret, and then you create a provider object, which every provider that you install actually installs a provider CRD, which we can look at once again here. Let's look at provider GCP is the first one that came up. And then if we look at the actual provider object, this is a CRD. If we look at the spec, that basically just references a secret. And then from each of the managed resources you create, you're going to have a reference to this provider object. So basically a provider just says, this is a set of credentials that I use to authenticate when I provision this resource. And when you create a resource, let's look at a network, you are going to have a provider ref here. So this field is on every managed resource, and you just point that at that provider object you create. So if we look at AWS, for instance, you'll see that we're creating a secret with our base 64 encoded AWS account credentials, and then an AWS provider that references that credential secret and also has some other metadata like the region for AWS. All right, so that is kind of a very rapid, quick overview of how installing Crossplane works. We haven't really gotten to actually contributing and building things, but I want to stop for just a moment and see if anyone has any questions right now. Keep in mind that there's still a lot more to get into to understand, so we don't want to spend too much time on this installation process.
I have one quick question. Might not related to what we have discussed, but it is related to etcd designing, like how we are distributing our metadata when we created those CRD, where we have our metadata stored, or what's the design we followed.
Let me dig into that question a little more and see if I understand what you're saying. Are you saying how do we basically specify what CRDs get installed when we install a provider?
Kind of, and where we store our data, metadatas for each custom CRD, because best practices is we don't store metadata on the same etcd, because in case one etcd goes down, so we have lost our CRD, right?
Yep. So basically, well, I think that was Rahul who asked that question. My view is a little messed up on my Zoom. But essentially what he's saying is when you create resources, custom resources in Kubernetes, they're stored in your etcd cluster, which is your key value store that Kubernetes uses. And so in this case, we are actually, for any of the providers we install, we're using the same etcd cluster, unless if you set up Crossplane to run against different API servers, which you can do, but it's a little bit out of scope for what we're going to talk about today. How we get around that, because it's really important that you don't lose your infrastructure state when you're provisioning external infrastructure, is that we allow you to use tools in the Kubernetes ecosystem like Valero, where you can back up your CR instances and restore them back into the cluster. And so that way, if you lose your etcd cluster and lose all your information, you can just restore it from a backup. So that's kind of how we get around that. We actually have a TBS episode tomorrow with Valero. So if you're interested in learning more about that, feel free to tune in.
Cool. Makes sense. Totally makes sense.
Awesome. All right. So typically when we're provisioning managed resources, we talk about doing it either statically or dynamically. So if you do it statically, you're actually creating a resource directly. So Here we're creating a cloud memory store instance. We're saying the provider ref, so we already created that provider, and we're just referencing it from the resource, which you have to do to be able to tell the controller how to authenticate to the API. And then we're also telling where to write the connection secret. So for some resources, this is not really applicable, but for a cloud memory store instance, for instance, you may have a password and a username and that sort of thing. So what you specify here is where that secret will be written with the connection information. Reclaim policy, we won't get into too much today, and that may be changing anyway. And then in the for provider stanza, this is things that are actually specific to this resource you're creating. So everything that is exposed by the cloud provider API should also be exposed on the custom resource. So we basically are saying, if you can do this with GCP Cloud Memory Store Instance when you're creating it in the console or via the API, you should be able to do it with Crossplane as well. This is the minimal required fields on a Cloud Memory Store instance here. There's also a lot more of them. If we looked back over here, let's take a look at Cloud Memory Store Instance. You'll see that there's quite a lot of fields in the for provider section. So you can configure those, and they all need to be supported in a v1 beta 1 resource, which is the API quality of Cloud Memory Store Instance right now. So when we create a Cloud Memory Store instance, our controller for the Cloud Memory Store instance is going to pick that up, and it's going to say, hey, I see that you created this. I'm going to go create this on GCP for you. It's also going to persist the status on GCP back in the status of the resource. So for instance, in this cluster I have here, let's see what resources I have created. So a good one to look at would be this AKS cluster here. So it is already provisioned, so we can take a look at it. And let's just look at the spec and status here. So as you go up, we'll see different parts of the status. This is actually a v1 alpha 3 resource, so it may not support every field that AKS does. But you'll see some of the spec here has been populated. Not all of this was things we provided values for. Some of them get populated. So if it's something that's customizable and you don't set it, but the cloud provider picks a same default for you, we set it for you in the spec so that you know kind of what your resource actually looks like, and you can also modify it later on. So if you created this resource directly, it would not have a class ref or a claim ref, and the status would be unbound. So you wouldn't see this bound status here. So basically, this is your typical kind of like infrastructure as code scenario. You're creating a resource and it's being provisioned, great. And you're able to manage it from your Kubernetes cluster. So that's kind of the simplest conceptual model. When you create a resource, you can also claim it with a compatible claim type. So in this case, a Cloud Memory Store instance supports Redis. So we can claim it with a Redis claim. And if you remember when we looked at that earlier, it had class ref, class selector, resource ref, etc. In this case, we've already provisioned our Cloud Memory Store instance, and we want to bind to that specific one. And so we're going to reference it directly. So when we create this claim, it's going to immediately bind to that Cloud Memory Store instance if it is provisioned and ready. And what that does is you'll see that we have a namespace on this Redis cluster. Claims are namespace scoped. So they're meant to say, I want to claim this here because I'm going to consume it here. So you may have like a deployment that you inject the credentials that are in this write connection secret to ref secret. You use those to, connect to the Cloud Memory Store instance from your application. So the managed resource itself, though, is cluster scoped. So you'll see when we got this Cloud Memory or this AKS cluster earlier, we didn't specify a namespace that's because it exists at the cluster scope. But if we look at the Kubernetes cluster claim, which is the generic type that can claim a AKS cluster, an EKS cluster, GKE, etc. If I spell it right, we are going to see that it exists. It's also bound. And if this is actually in the default namespace, so it's just getting that automatically. But if we were not in the default namespace or we provision the claim in another one, you'd obviously have to specify the namespace there. Since it is bound to this AKS cluster, that connection secret that we specified where to write it to on the AKS cluster or on the cloud memory store instance in the scenario we're looking at in the docs is propagated to the namespace. So we basically say, okay, this infrastructure was provisioned, it wrote its secret information here, and we're gonna put it in this namespace because this namespace is where we're gonna consume it. So actually, let's take a look at the spec of this claim here. And you'll see it has write connection secret to ref, test me cluster. And then in the metadata, you'll see we're in namespace default. So we're basically saying we want the connection information propagated to test me cluster secret in the default namespace. So if we then look at the default namespace, the secrets there, we see this test me cluster resource. And if we looked at the fields, we'd see things like kubeconfig information, that sort of thing, since it is a hosted Kubernetes offering. So you may want to be able to provision things in a reusable manner using kind of like a templated approach though. And that's where dynamic provisioning comes in. And so for every managed resource we also have a cloud memory store instance class or a class for whatever resource it is. And it's going to look very similar, except instead of spec, you'll see spec template. And you also see some different metadata fields here, like write connection secrets to namespace rather than an explicit reference. When you create a class version of a managed resource, it doesn't actually do anything. There's no controller watching for the class. It just exists in your cluster at the cluster scope. And it's basically saying this is a recipe for creating cloud memory store instances later on. Then I may want to use this fields and configuration multiple times. So when you create a class, you can then create a claim. So once again, creating a Redis cluster claim, and you can reference that class. And when you do that, the claim controller for GCP in this case is going to actually produce a cloud memory store instance managed resource, which then gets picked up by the managed resource controller for cloud memory store instance and gets provisioned on GCP. Once it becomes ready, it becomes bound to the Redis cluster claim. So it's a similar, you get to the same state, right? But you're kind of doing it in a more repeatable way. And you can imagine an organization, this separation of concern is really valuable because you may have application owners who say, I want a Redis cluster. I don't really care, what cloud provider is supporting it. I trust my infrastructure team to have set up some classes. So I'll just create a claim and let it provision the infrastructure for me and give me that connection secret back. So it's useful, but for this case, you have to know that the class actually exists and reference it by name, API version, and kind. You can also use a class selector, which allows you to match classes by labels. So for here on the cloud memory store instance class, we have this guide quick start label. So we're saying we want to match labels to guide quick start for the class we select. This can be really valuable because it's another kind of layer of abstraction for an application owner. Because let's say you have a cloud memory store instance class, and then you have a replication group, which is basically AWS's version of a Redis cluster you can provision. And on one of them, you had, tier primary and tier secondary were the two different labels you had. Well, depending on what the Redis cluster person wants, if it's like a development scenario, maybe better options would be like tier dev and tier prod. Then they could put in their class selectors tier dev, and they could say, I don't know where this is actually coming from necessarily, but I know I want whatever my infrastructure team has specified as the dev resource that we want to use when provisioning Redis clusters. So from there, the actual cloud memory store instance is going to get created, and you'll see on the claim that it has a class kind. So we actually did dynamic provisioning in this case I was looking at earlier. So when we get the Kubernetes cluster, you'll see that we used the AKS cluster class named test AKS cluster, and it provisioned the actual AKS cluster default test me cluster 478JT. And then the controller went and provisioned that on Azure in this case. So that just serves to kind of show you what the user experience is. Obviously, most of you are more interested in contributing to the project and then potentially using it as well. There are some other concepts here, including scheduling workloads, stacks, and applications that are kind of higher level, layered on top of these managed resources. that we will not cover today, because you won't have to worry about them when you're actually contributing to a specific provider. One other thing I wanted to mention is that we are doing some work, and I mentioned this at the beginning. Movafic specifically has done a lot of work and a lot of design around this for composition, which could lead to the deprecation of claims essentially in the future. And basically what composition says is I want to be able to define a new type of claim. It's called a requirement, if you will, that will provision multiple resources together. So you can imagine if you're creating a Cloud SQL instance on GCP, you may want to also provision a network and a subnetwork and then put the Cloud SQL instance in that and have references between them. That's what composition solves. Once again, from a provider perspective, you don't necessarily have to worry about that as much, but you will see how we support claims right now and how we may not need to in the future. But for now, we will just look at what we do support. So I will stop for a minute there before we actually get into some implementation here. Does anyone have any questions? It looks like we are about 40 minutes in, so about 20 minutes left. So once again, I don't want to spend too much time on this before we get deeper in, but does anyone have any immediate questions? All right, sounds like we're okay. And Movafic, of course, you are more than welcome to jump in here at any time as well. I also can't really see the chat, so if you're dropping things in there, Movafic, if you wouldn't mind responding to those, I would really appreciate it. All right, so we looked at those managed resources and how people use them. So let's talk about how you actually add these to a provider. So all of the struct code, the Go code for our custom resource definitions, so defining the different types, is in our APIs directory on each provider. So we're looking at provider AWS here. You'll once again see these different groups, and those correspond to the group that you'll see on a CRD. So cache GCP crossplane.io. I'll move this over to AWS for now, so we can see stuff. I'm going to do RDS instance for the examples today, so I'll have that up here. So it's going to be in the database.aws.crossplane.io group. See the version and kind. So you can find that easily in the repo as well by looking in the database group. And then the V1 Alpha 1, oh, I'm sorry, I'm in Crossplane. Looking in the database group in provider AWS, looking at the V1 Beta 1 group. And you'll see here that we're registering the different types here. So we have RDS instance and DB subnet group are two V1 Beta 1 types in the database group for AWS. And if we look at RDS instance types, this is where we're actually defining the fields that are present on an RDS instance here. So you'll see a lot of these smaller structs here, they get embedded in a larger one. So the main one, the one that goes under the for provider part of a resource, is going to be called, let me collapse this so we can see the specific part. So for provider, this is where the actual provider specific fields go. Those are generally represented in the resource parameters struct, so RDS instance parameters here. So here you'll see a bunch of different fields, and then you'll also see some embedded structs, some of the ones we saw earlier. You also see some of these tags, which we have documentation on, and whether it's required or optional, or that sort of thing. And if you want to look at the documentation on how to provide those tags and what our kind of standards around that are, you can go to design and this awesome doc that Movafic put together. So manage resource API patterns. This basically tells you about how you add fields and what fields should go where, essentially. And so these are all different things that when we go and look at the AWS SDK or API, these are fields that are represented on a resource. When you have a V1 Beta 1 level resource or any beta level resource, you must support all functionality that the cloud provider does for that resource. So anything you can do via the AWS API, you should be able to do in the Crossplane representation of that resource. Importantly, fields that are represented by other objects in Crossplane. So for instance, we saw that we have DB subnet groups earlier. We have machinery in Crossplane to be able to kind of resolve names between different resources. So if the field is represented by another resource in Crossplane, you should also add a DB subnet group name ref, or whatever the field name is, ref, which will be part of runtime v1 alpha 1 reference type. And we'll talk about Crossplane Runtime here in just a moment. So basically what you're doing in this file is just defining all the different fields. And if we go down a little further, obviously RDS is a pretty complex resource here. You'll see that we have, let me look at the actual struct. So this is the kind of top level place for RDS instance. You'll see we're defining things like printer columns and that sort of thing, which this is used when we generate the CRD, which is a Kubernetes object from the struct here. These are all tags that will affect it, as well as those other ones you saw in the fields. And you'll see we're embedding the spec and status here. So the RDS instance spec, well, the status, you'll see we embed some common resource status across all managed resources, as well as the specific ones for this resource type. And then in the spec, which I'll find here, you'll see that we're doing the same thing. So resource spec and for provider is that RDS instance parameters object there. So that's generally what you're doing in the types file for any resource that you're adding. So for EC2, for instance, I know a couple folks are interested in that. If you've looked at the AWS API, it's a pretty complex resource. Starting with the alpha level, we may be able to simplify it a little bit to get some initial support for it and just kind of introduce it. It would be the first VM type that we introduce into Crossplane. We don't currently support any VM services, so there may be some interesting things around that, but in general, you do want to just represent all the fields that the AWS API will for a EC2 instance. You'll also see in all these types files for managed resources in a class version, which is essentially the same thing, except for it uses this spec template. So with the RDS instance class spec template, which is the same thing as the spec, except for it's using this embedded class spec template across all resource classes, and then it's embedding those provider specific fields. So that's like what we looked at earlier when we did dynamic provisioning. We had that Cloud SQL instance class, which allowed us to provision I think we were doing Cloud Memory Store instance class, which allowed us to use those fields to provision at a later time. So when you add these types and you register them with the controllers, when you run make generate in any of these provider repos, you're going to get some methods generated for your types. So those will just be created automatically for you. And then you'll also see that your CRD gets rendered out in the CRD directory. So we're looking at RDS instances. And you'll see that it gets presented here. And this is actually what gets parsed to produce our documentation here. So this is the same fields. Once again, they are just getting produced from the Go code. So after you've added an API type, you need to add a controller to be able to watch it and react accordingly and provision it on the external provider. The controllers go in the package controller directory generally, and they are once again separated by group. So if we go to database, you'll see we have an RDS instance controller here. You also see we have this claim file. Let's focus on just the manage resource reconciler first, and then we can look at some claim stuff if we have time. So essentially what the managed resource Reconciler is supposed to do is watch for creation of the resource, then go create it with the specified parameters on the cloud provider. If you're familiar with Kubernetes controllers, this may look a little bit different than what you've seen before in a project like KubeBuilder or something like that. Generally, you basically just have a reconcile function that you pass, and it just contains all of your logic for reconciling your resource. In Crossplane, we have common patterns across how we provision resources across cloud providers. And so all managed resources kind of adhere to this contract of being able to fit this managed resource reconciler. This makes it a lot easier for you as a developer to be able to specify what you need your managed reconciler to do, because we essentially expose just these observe, create, delete, and update functions, which basically are exactly what they say. What do you need to do each time you reconcile to observe the resource? What do you need to do if the resource needs to be created? What do you need to do if it needs to be updated? And what if it's deleted? You'll also see this connector struct here with a connect method. And this basically tells Crossplane how to connect to the cloud provider. So as we talked about earlier, your managed resource will always have a provider ref. So you'll see these connect methods are very similar across all resources in a provider. What they're going to do is get the managed resource from the API server, or it's actually going to be passed to them here. And then they're going to get the provider from the provider reference. And then they are going to get the credential secret reference off of that provider, and then use the information in that secret to be able to authenticate to the AWS API. AWS also allows you to use IAM roles for service counts, which is what this part is here. We're not going to talk about that today, but it's basically an alternative way to authenticate to AWS. So in order to understand everything that happens in the managed reconciler, which you actually don't necessarily have to do to be able to support a resource, you should look in Crossplane Runtime here. So Crossplane Runtime is basically where we put this shared logic that's used across our different controllers. So our reconcilers are in the reconciler directory, here. And you'll see things like claim binding, claim defaulting, claim scheduling, secret, target, and managed. Managed is what we're looking at here. So in the reconciler here, this is going to look a little bit more what you may have seen from Kubernetes controllers in the past. There's a lot of basically customizability of these different reconcilers that you're implementing. And so it basically allows you to pass in things to override our default behavior. For a lot of resources, you can just kind of rely on the default behavior that we select for you in terms of the machinery for the resource that actually happens in the cluster. If you do add a resource, we can obviously help you with reviews to make sure that you're passing in the right things. So you'll see some of these with functions that follow this builder pattern. And so if we look here, you'll see that we're passing some of these in here. For instance, the reference resolver is what allows us to reference other resources that were created in Crossplane and resolve names to pass to parameters and that sort of thing. It also allows you to do things like override the logger. These are all things that you're probably just going to go with these default values most of the time. What you will need to do is pass in your connector every time, which is this struct here. And so you're basically saying, I will pass the client to my connector function, and I'm going to return this RDS client, which is just from AWS. And we'll get into the client stuff we do in Crossplane as well. But if we look in the manage reconciler here, we're basically going to sequentially call these different methods that you give back to us. So let me go all the way down to our reconcile loop here. So the first thing that we're going to do is we are going to get the manage resource. So once again, this is happening behind the scenes for every manage reconciler that we have. And after we get the manage resource, we are going to do some things like adding annotations. And then we're going to get to where we actually use the methods that you pass to the manage reconciler. So the first thing that we're going to do is call your connect method. You're adhering to a contract with your connect method that you're saying, okay, given the context and the managed resource, I'm able to figure out the credentials that the cloud provider needs for us to be able to authenticate, and I'm going to return that client to you, which has these methods defined on it. So we're returning this external here, which in this case is going to be our external struct here, which needs the RDS client and the Kubernetes client. And these methods are defined on the external client. So we're returning this and saying, you can now call these methods and it's going to know how to basically connect to the AWS provider or the AWS API. So after we connect, we get back that external. We're going to do some things like initialization. Once again, these are things that you can usually use the defaults for. And then we're going to go about actually reconciling the resource. So this is heavily documented code here. So I would advise you looking through this if you'd like. Once again, you can kind of start off with actually just kind of taking it out of the box and seeing what works and what doesn't. But we do explain in pretty good depth here what is actually happening. So the first thing we're doing is checking if the managed resource has been deleted. That is, it has a deletion timestamp on the Kubernetes object. If it was not deleted, then we're going to resolve our references. Once again, those are references from Crossplane objects to each other that get resolved and set parameter values for you. That's a little bit more advanced, so we can talk about that more potentially in a follow-up meeting. Next thing we're going to do is observe the object. So observe, we're saying, let's reach out to the API for the cloud provider and get back the status of the resource and then decide what action we need to take based on that status. So for RDS in our observe method, what we're doing is we're describing the DB instance. So we're saying, okay, using our name of our DB, let's see what status it has. Based on the status we get back, the first thing we do is we late initialize values. So as you may imagine, a lot of these values in for provider here are not, they are not things you have to provide. In fact, if you want to know if you do have to provide them, you can look at required fields. So actually all you need to provide for an RDS instance is the engine and the DB instance class to be able to provision one, as well as some of the other fields like the provider ref. But these are the only parameters that actually get passed along to AWS that you have to have. AWS and other providers will often pick some default resources for you or some default fields for you. So when you create an RDS instance, for instance, if you don't specify the allocated storage, I believe that it will pick one for you. In this wall of text here, I'm sure it tells you. I am not going to figure that out right now. But if it does select a default value for you, we actually set that on the spec for the user. So like when we looked at the AKS cluster earlier, let's see if I can get it. I did not set all of these values in the spec, but they were updated after they were created. For instance, I don't think I set the node VM size. I might have, I can't remember. But if I didn't and Azure selected one, we want to go ahead and late initialize with that. So update the spec of the resource so that when we compare what we supplied and what's at the cloud provider, we know if we actually need to take an update action. Because if we didn't specify a field and we let the cloud provider pick it for us, we don't want to try to update it to, you know, basically wipe out that field because we basically have said as a user that we are fine with the cloud provider default here. So that's what the late initialize does here. We'll look at that in just a moment. Next thing we're going to do is look at the status of, or set the status actually, of the managed resource. So we're basically saying based on what AWS gave back to us, we want to propagate that to the status of the resource. So once again, this is something like the Azure gives us back the provider ID and the endpoint and the state. So we put all of those in the status of the resource. So basically any information the cloud provider will give, we want to add that to the status. So that's what we're doing here. And then based on the status of the resource, which you have to know what the different return values from the provider tell us, we're saying we need to take a different action. So the first thing we did here is that if the resource didn't exist, we're going to return an empty external observation, which is defaulting to resource exists false. So let's kind of go through that branch of logic here in Crossplane Runtime first. So if we get back from the external observe that this observation, which is that struct that tells if the resource exists, as well as some other things, we'll skip whether the resource has been deleted and go down to observation resource exists. So we've said back in this case that the resource does not exist. Once again, this gets initialized to false if we don't provide a value. So we would get to, if the observation says that the resource does not exist, then we want to go ahead and create it. So you'll see there that we're once again using external to call create. And if we look back at the resource, it's going to call this create method. Here, we're basically using the spec that the user has provided on the resource and submitting that to the AWS API and saying, please create this for me. And then reporting back if it has an error or if there's connection details. You'll see that for each of these methods, we have a custom return type. So the external observation has some fields that need to be reported. External creation has connection details. I believe update also may have connection details. I'm not sure. We're not propagating them here. And then delete is just error or not. So based on the return values of each of these operations, we take action. So here we're going to create. If that does not fail, then we're going to publish the connection. So for instance, in the creation step here, we're returning some connection details. So Crossplane Runtime is going to say, okay, we're given some connection details. Let's publish those. Publishing is basically just writing to the secret. You can override that. You'll see that we're using the default here that's passed in. You could pass in your own connection publisher. So maybe you publish it by writing it to a vault instance somewhere, something like that. So that could be something you set up. And if we do get to this creation block and everything works as expected, then we are going to end this reconciliation and then try again in a short wait. So basically we're going to observe it again after time and keep observing it until it reaches the steady state where we are essentially getting to this point where the resource exists, it is up to date, and we're propagating any connection details that we get. So the important parts of this are determining the status, doing late initialization, and checking if a resource is up to date. So this is usually the most complex kind of handcrafted part of it. And this is in the client's directory for a resource. So let's look at RDS here and rds.go. So we have these methods that we're calling from the controller. So we usually have a generate kind of method, which is taking the crossplane representation of a resource and creating the AWS API representation. So a lot of times there's kind of some differences in how the fields are represented on a Kubernetes custom resource and how they're represented in the RDS object that AWS actually expects. So we're basically doing that translation here. So doing things like going through slices and appending things and that sort of thing. This has create patch as well, which is kind of specific to RDS and some AWS stuff. So we will skip that for a moment. Here we're generating a modify request. So this is in the update method. We're going to use this. Basically, any type of object that you need to submit to the AWS API, we generally put the translation from the custom resource into that struct type that the AWS SDK is expecting. We put that code in the client package. Here we're generating an observation, which is taking the response we get back from the AWS API and creating basically the thing we embed in the status. So these are all just kind of like helper methods to do this translation between AWS and the custom resource. You'll see that that can be a bit complicated. And then the probably most hard to grasp part from the beginning is this late initialization. So this is what I was talking about earlier. When we let the cloud provider default to values, what we want to do is set those values in the spec of the resource so that the next time we reconcile, we don't think we need an update because we didn't provide a field and the cloud provider did. So this is basically checking every field and saying, is there an existing value for it? If not, we don't want to if there is, we don't want to override it. If not, we'll set that to whatever the cloud provider chose because the user has said, I don't care about this field essentially. So it may take some time to kind of look through the different parts of this, but RDS is probably one of the most complex examples, so it may be useful to look at a more simple resource, but you'll kind of get an idea of all the complexities of it by looking at something like RDS. Last thing is checking if something is up to date, which basically is saying, do we need to update it? Have we changed fields that are not represented in the cloud provider? RDS is actually pretty simple. You can kind of create this patch and compare the two. For some resources, especially some in GCP, we have to do a little bit more complex operations to determine if there's a difference between what the cloud provider is saying and what we're saying. But in general, it's that same sort of logic. We want to make sure that everything that the user has selected on a resource is then also reflected in the cloud provider. Last thing here is getting some connection details. So this is basically getting things back or pulling them actually off of a RDS instance and being able to write them to the connection secret. All right, that was a whirlwind of information, I know. We kind of had to breeze through it by necessity there, but we are kind of at the end of the time specified for this meeting today. Like I said, I'd love to follow up in a separate one. I'm going to stop sharing just so I can see everyone again. If it'll let me stop sharing. One moment here. Let's try. Well, I'll keep finishing up. Okay, there we go. So I know there's a lot of information, and so I don't expect everyone to grasp it immediately. Really getting into the code and trying to add things is going to help. You can start with one field and kind of build up from there, or start with the required fields and build up from there. And we are obviously here to help along the way as well and answer any questions and have more meetings like this. But are there any kind of parting questions for this meeting with considering that we are kind of short on time here that anyone wanted to bring up?
Hi, Daniel. Alok here. So we have a few questions, but I think, yeah, that's going to take some time. So quickly, when you mentioned is up to date, is there a default implementation or do we have to have those is up to date always implemented if I'm calling that?
So there is not really a default. A lot of times you can kind of, if you have that translation method where you've already translated the custom resource version to the cloud provider version, you can actually just take that, do that translation, and then do, we frequently use the compare library, which is from Google, I think. And we just say, is there a diff between these two? And if so, it's not up to date. Some resources require a little more hand-holding to be able to figure out if they actually are up to date or not. But the generic implementation would basically be just compare these two structs and see if the fields are the same.
And that's already done as part of this. So if I just make sure that as part of create, I set the proper flag if exists or not. And similarly, during update and delete, I should be good to go.
Yeah, in the observation method, yeah, that's where you check whether it's up to date or not. And if it is, then you return true. If not, you return false.
Okay. And then one quick question I have is, so this claim in class method model that we have, is this supposed to be followed for every resource types? Let's say there's an IAM policy, there are certain things which are not feasible listed. So what?
Yeah, that is an excellent point, and that's one of the reasons why we will likely be moving away from having claims. It's not really sustainable for Crossplane to be able to keep up with every provider that ever exists and add generic CRDs that represent anything something can bind to. So with composition, we're basically allowing for users to define their own claims, and so in the long run, no, claims are not something that's necessary. And then for resources right now where we don't have claims, like a lot of those IAM resources are good examples. They're not really something that can be represented abstractly across providers. For those, we just don't support dynamic provisioning right now, which is kind of a hole in the system. So composition, which was added in 0.10, and we could probably have a whole call on that where move off it could give you lots of information that I don't even understand yet. That's going to solve some of those problems and allow you to stitch some of those things together.
Yeah, that's what I was going to follow up. So I think composition class session is much needed now for at least. Cool.
Definitely.
I think I have everything. Thank you so much.
Cool. Muvafik, were you going to mention something?
Yeah, I was gonna mention like after the composition, we will actually don't have like the classes as well, like the RDS instance class, because we will basically use a generic class for like, defining several resources that will bind to one claim that you have, like that you yourself defined, like a either generic claim or like a claim that is specific to your organization.
For sure. Yeah, that's a great point. So once again, those classes that we specified at the end, where you kind of just embed the provider spec, you won't have to do that anymore as well.
Yeah.
All right. Well, like I said, this has been a lot of information. This is recorded, so hopefully we can share it out with the community as well. I really want to thank all of you for taking an hour out of your day. I know a lot of you are on different time zones, so it's later at night for you. So I appreciate you sticking around and hanging on this call. It is, our pleasure to help new folks get onboarded into the community. So anything you need from us, any questions you have, any follow-up sessions you want to have, please let me know, and we will get those set up as soon as we possibly can.
Thanks for the meeting, Dan.
For sure.
Thanks. Great overview.
Yep.
Thanks, both of you.
Everyone, have a good day.
Thank you. Bye-bye. Take care.
Bye-bye.
Thank you.